In this session, let's solve some practice questions on sets. Okay. Without wasting much of the time, let's start. Let's say with the first one. Let's say you're given set A is this, B is that, let's say C is something like this. Excuse. So now, then we're taught to find, let's say we're taught to find A intersection B and A union B. So how are we going to solve these sets? Okay, so this is what we call sets application. You're applying sets now to real life problems. So let's say this is our number line that you're going to use. Okay, now we've got our sets. So before you solve, at least put your sets on the number line first before you start determining the questions. So now you're able to see that let's start with A. We're saying we're moving from 1. Let's say 1 is here. Let's say this is 2, this is 3, 4, 5, 6, 7. Let's say A is from 1 to 7. Now you're able to see that 1 is 1 included or not. You're able to see that it's an open, so what you are going to do, it will also be open. That's why we learned about set intervals. So this will be open. Now you're going to 7. Now is 7 included? Now you're able to see that 7 is included. So even here you're going to close. So this is our A. Okay. Now let's put B. If we say B is from -2 to -3, okay. So let's say this is 1, this is 0. Let me use the uniform color. This is 0, this is -1, this is -2. Okay, even just like that. Now for B we're saying you're moving from -2 to 3. Now is -2 included? You're able to see that -2 is not included, so you're going to put an open. Now you're going to 3. Is 3 included? Yes. Then what do you do? Join the points. That will be the interval for B. Now what do we now do? The first question is we're told to find A intersection B. So if we're finding A intersection B, this is the region that we want. So that is the region that we want to find. That is A intersection B, because this is B and this is A, and we're trying to find what is common in between them, and is that what I've highlighted. So now what is the answer according to what we've shaded? You're able to see that now our A intersection B will just be equals to, we're starting from this region and we're ending from that region. So what do we have? We're starting from 1, but now is this 1 included or not? Is it found in both sets? No. 1, yes, 1 is found in B because B passes here, but 1 is not found in A, so it can't be part of the intersection. So we're going to open, comma. Now we're going to the last point, which is 3. Now is 3 found in both B and A? Yes, you're able to see that it's included in B, but it's also part of A. so 3 is included. So this will be our solution for A intersection B. Now how do you find now A union B? So your A union B, that will just mean that you are combining A and B. Now, like I always said, you always start from the smallest to the largest. In terms of intervals, you are combining everything. So you're starting from this point and we're ending to that point. So let's start with the first point, starting with -2. Now, is this -2 included or not? You're able to say -2 is not included. Okay, so you comma, we're going to this point, we're going to the last point. The last point is 7. Now, is the 7 included or not? This is included, so 7 like that. So that will be our A union B. So that's how you solve this question. Let's solve another one. Let's say you have okay, let's draw a number line in advance and you ask questions on. Let's say this is our number line. Okay, let me put it like that and let me put it like this. Okay, so let's say this is A, this is B. Then our numbers, let's say this is -5, let's say this is 1, let me say this is 2, this is or even the same 5. Okay, then let me say this is open, this is closed, this is let me say this is also open, then let's say this one is closed. And now they've asked us to find A intersection B, and A union B. Okay, so what would be our A intersection B? What is found between A and B, or what is common between A and B? So are these two sets meeting anywhere? No. So our A intersection B in this case would just be an empty set, or just the same as an empty set, and a set without anything. Don't put anything inside here. It will mean it's not an empty set, but if it's like that, it's an empty set. Then what about our A union B? A union B, you are combining what is in A and what is in B. So meaning our A union B will be, remember we always start from for an interval, you're always starting from the smallest to the largest. So we're going to start -5. Now -5 is not included, so comma 1. 1 is included, yes. So you close like that. Now you're uniting this with B. B is starting from 2 and it's going all the way to 5. 5, is it included? Yes, you close. So this will be the solution for that expression. Now let's solve another one. Let's say you are given to find let's say A is equals to 0. Let's say 0, you're going to 5. B is, you are moving from -2 to 3, and the universal set is from -4 to 7. So how do you solve when you are given to find the, let's say you're given to find the, let's say A complement. Let's make it a bit interesting. A union B complement. Let's say also given to find A minus B. Okay, so how do we solve this? Now I must make mention that never forget the universal set. If they have not given you, then the universal set will be a set of odd numbers. So if they've not given you this universal set, or where the universal set is starting or where it's ending, please always assume or take the universal set as a set of all real numbers. Okay, so let's start with the first one. Allow me to write it there. Let me draw a number line. We're trying to find A complement intersection B. Okay, so if this is our number line, let's start with A. We're saying we're moving from 0 to 5. Okay, let's say, let me put the numbers. Let's say this is 0 and this is 3. Let me say this is 2. Okay, 3. We're going up to what? Okay, 3. Let me say 5. Let's say 7. On the other side, let me say -1, -2, -3, -4. Okay, now let's put A. We're moving from 0 to 5. Okay, so because 0 is not included, I'm going to open. 5 is not included, I'm going to open, and I'm going to join these 2 points. This is our A. Then we come to our B. Our B is -2 to 3. So -2 is there, so I'm going to put a circle here, and we're going all the way to 3. 3 is there. Now, is -2 included? Yes, so I'm going to shade. 3 is not included, so I'm going to join these 2 points. This is our B. Then our universal set. Our universal set is from -4 to 8 to 7. Now -4 is included, 7 is included. So everything from here to there, that is the universal set. Our universal set. So these are the sets that we have. Now we're trying to find A complement intersection B. That is our A. So A complement, it is what is not found in A. So let's put A complement on this our diagram. So what are we going to do? Allow me to use a different color for A complement. So because 0 is not found in A, it means it will be found in A complement. Now for 5, because 5 is also not found in A, we're also going to put we're going to shade it, and we're going all the way up to 7, and this side you're going all the way up to, okay, pardon me on that one, not really drawn to scale, but you're moving all the way up to 4, and 4 is included. So this is A complement, and this is A complement. Now we're trying to find the intersection between A complement and B. So where else do they meet? You're able to see that if I go on my right hand side, this has nothing in common with B. So I'm going to ignore that part because it can be part of the intersection. If at all A complement and B have an intersection. Then we've got A complement this side and we've got B. At least they're meeting somewhere. So that's where the region I'm going to concentrate on this region. So let me shade until to there. Now you're able to see that is the intersection between the two. So now what is our solution? Our solution for A will be from -2, 0. Now I should ask a question. Is 2 included, or is it in both the sets? Yes. So I'm going to do that. Is 0 in both sets? Okay, yes, 0 is also in both sets. So that would be the solution for the first expression. Then the next question is A union B complement. A union B complement. Okay, so you want to combine A with B complement. Let me just add B complement on our Venn diagram. So if we have our B and this is our B complement, if 3 is not in B, meaning it will be in B complement, right? So we're going all the way to 7. So this is B complement on this side. On the other side, so because negative 2 is included in B, so we're not going to close it. So this is also another part of B complement. So now we're trying to find the union between the two. So what would be our solution? Our solution for B will be okay. Our solution for B will be what? So you are moving from negative 4 and you're going to negative 2. Okay, negative 4 to 2. Okay, so this is negative 4. You're combining all of them to 2. 2 is not found in B complement, so meaning you're going to close their union. And what other part of the two sets? Union 0, 0, 0. A is from 0 to 5. So 0 is not found in A, but it is found in B. So you're going to include it. Okay. 0 to where is B complement ending? B complement is ending at 7. So 7 will be like that. Yes, so this will be the union between A and B complement. Then the last question is A minus B. You want A, but you just don't want B. Okay, so what would be A minus B? If our A is from 0, it's from 0 to 5, and we don't want B from A. B A minus B. So A minus B is just the same as A intersection B complement. You're trying to find what is common between A and B complement, and we found B complement. Our B complement is that what is in blue. So what will be the intersection between these two? So it will be that region. Okay, so now what will be our answer for the last one? If it's that region, meaning you want you move 3 to 5. Now, is 3 included in that expression? Yes, you're able to see that 3 is in B complement, it's also in A. So here I'm going to close. Okay, then is 5 included? 5 is found in both as well. Okay, 5 is found in A. No, 5 is found in B, but it's not found in A. So I'm going to open. Okay, because we're trying to find the intersection between the two. So here I open. So this will be the solution for that one. Okay, so let's solve another one. Let's say you're given to find let's say this is question number 4. A is equals to -3, 2. Okay, B is 0,7. Then C is equals to, let's say, -5,1. Then the universal set itself is let's say from okay, let's make it this we say the universal set is from, the universal set is from 10 to 10. 10 to 10, all of them are not included. So our questions, let's just put two questions. Let's say you've got you're told to find A intersection B complement, which is the same as A minus B, and you're told to find A minus let's say B minus C. Then there's a complement outside. So okay, this is now interesting. So now how do we solve such a question? So allow me to draw the number line. Okay, allow me to draw the number line. Let's say this is our number line. Okay, and let's put these figures one by one. So let's start with A. A, we're saying is from -3 to 10, from -3 to 2. Okay, so let me say, because our universal set is from -10 to 10, that is our universal set. So let me say this is -3, this is 0, this is a 2, let me say this is a 7, okay, like that. Then we're trying to find A. A is from -3 to, so it's from -3. Is -3 included or not? You're about to see that -3 is not included, so I'm going to put open. I'm going all the way to 2. Now, is 2 included? Yes, you are able to see that 2 is closed. So that is our A. Then let's put our B. Our B is from 0 to 7. So let me say, is 0 included? Okay, both 0 and 7 are included, so I'm going to close, and at 7 I'm going to close. So this will be the interval. This will be the interval for B. So this is B. Now we're trying to find the intersection between A and B complement. So let's put B complement. So B complement is what is not found in B. So you're moving from here and going to this. Then again from this side you're moving from here, going all the way to this 10, -10. Then we're trying to find the intersection between the two. Okay, so what would be the intersection? So I'm going to indicate the intersection between A and B complement. It is, so I'm about to say that on this side there's nothing that is common between the two. So this is B complement and this is B complement. So only this region is common between A and B complement. So therefore what is now the solution set for this expression? So you're able to see that let's say you are moving from -3 to 0. Okay, so -3 to 0. But now, is 3 found in both sets? Is it found in A? 3 is not found in A, so it means we are going to open here. Is 0 found in both A and B complement? 0 is not found in B complement, but it's found in A, so we are going to open as well. So this will be the solution for A intersection B complement. Okay, now let's solve the next question. Very interesting question. Allow me to rub this expression. So for the second expression, at least you have to first simplify it before you show it on a Venn diagram, okay, or on a number line. Okay, so that is very important for you to know. So we've got A minus. Now the minus is just the same as an intersection, right? And when you introduce an intersection, you remember if we had A minus B, we said it's just the same as, these are two sets, this is A and this is B, two sets. So you're going to say A, the minus becomes an intersection. Now because you've introduced an intersection, the B will have a complement. Remember, this is called the difference law. So even in our case, we're going to do the same thing. We've got two sets. We've got A and we've got B minus C complement. So we're going to do the same. We're going to say intersection, right? The minus associated to the intersection. Then B minus C complement. This is a set on its own, but because we've put an intersection, we have to put another complement. Okay, so that's what we have. Now what do we now do? A complement and the complement will cancel. Okay, so we have A intersection B minus C. Okay, then what do we have? What is in the brackets, we can also simplify it further. So we're going to say A intersection B intersection C complement. That's what we have. Okay, so can this be solved further? Okay, now that we have that, let's now do this on a number line. We see how it will look. Okay, we see how it will look on a number line. So we are saying for A we said it's -3. So let me just put the numbers negative. We're moving all the way to 10. So let me put numbers -5, let's say -3, let's say 0, let's say 1, let's say 7. Okay, then let's put our A we said is from -3 to 2. So -3 is not included and you're moving to 2. Let me put my 2 there. Apologies for that. Let me put my 2 there. 2 is included, so I'll put it there. Then this is our A. Our B we said it's from 0 to 7. So let's say 0 to 7. Both of them are included, so I'm going to 7 like that. This is our B. Our C is from -5 to 1. So -5 to 1. Let me say this, because -5 and 1 are included, so I'm just going to circle in advance, and 1 is somewhere here. Then we join them. This is our C. Now we're trying to find the intersection between A and B intersection C complement. Okay, so first and foremost, find what B intersection C complement is. Then after I find that, then I'll find the intersection between what we found with A. Okay, so let's find first B intersection C complement. So it means we have to find what C complement is. So C complement will be from this point and you're going all the way to 10. Now remember that 10 is not included, so I'm closing, I'm opening. Even this side, you're going this side and you're opening. So this is C complement, this is C complement. Now trying to find the intersection between B and C complement. So in that regard, on this side it has nothing to do with B, it only has something to do with C. So on this side, that's where we're finding that that's where they've got something that is in common. So we want this part. Okay, so that is our B intersection C. Okay, now that same part, now we want to intersect it with A. Okay, remember we found this part, which is the one that we shaded. Now we have to intersect that with A. So let's intersect that with A. So A is this region. Okay, so if we're going to intersect the two, so this will be our solution. Okay, so if this is our solution, what is the answer then? So you're moving from 1 to 2. Now is 1 included? one is found in A. It's also found in the intersection there. So we are going to open, we are going to close. Then for 2, is 2 included? 2 is found in A, 2 is also found in the other set, so you are also going to close. So this will be your solution set. That is very, very important for you to know. Now let's talk about the last part. How do you shade sets? Okay, shading sets. Okay, so if you are shading sets, let's say you are given to shade A union B union A complement. Now always simplify first before you solve. Okay, so A union, you distribute the complement. When you distribute the complement, the complement will fall on B, right, according to De Morgan's law, right? Then what will happen to the middle sign? It will change to intersection, right? So intersection A complement, like that. So now that you've reached here, we're able to see that, what did we say our union is what does it symbolize? In terms of symbols, we said union is just the same as or at the same time union is just the same as multiplication. Then in terms of the intersection is, we said it's the same as and, that is then the other operation that you can use is a plus for the intersection. So this expression is just the same as if I say 2, this 2 is multiplying by, let me say, B plus A. So what do you do when you go such an expression? It means you're going to distribute 2 throughout the bracket. So that's what we have. So it means we have to use what? The distributive law. So A union B, we're going to distribute it throughout the bracket. And when you distribute it, what are you going to have? You're going to have A union B complement. There's an intersection. Then you're going to say A union A complement. So those are the things that we have. Then remember, from our identity laws, we said there's what we call the idempotent laws. Now the idempotent laws is about, if you've got A and this A is distributing throughout, you have to understand that if we're going to say A, let me put this in a Venn diagram. Let's say this is A. Okay, A, this is a complement. So A and this complement. So if this is A, you are trying to unite A and this complement. Complement of A is what is found outside A, right? So what will be your answer overall? You're going to realize that this is just the universal set. So you're trying to find the union between A union B complement intersection universal set. Okay, universal set. Now we said the universal set is the overall set. So if it's the overall set, everything will just be a subset of it. Now what is common what is found between the universal set and a certain set? It's that set, right? So our answer therefore it is A union B complement. Now how do we shade? Now that we've simplified, how do we now shade this set on a Venn diagram? Let's say this is our Venn diagram, though not drawn to scale. Okay, let's say this is our universal set, and we've got, let's say this is A and this is B. This is A and this is B. Now we're trying to find A union B complement. So how are we going to shade this? This is the answer that we found, but how do you shade that? So if we're going to shade that, let's first shade the A, because let's combine the two sets. So A is this part. Then B complement, it is what is not found in B. So what is not found in B, allow me to shade it using a different color. So what is not found in B is this. Okay, so you have shaded, and that's how you shade the sets. Then let's solve the last one. Okay, let's say you are told to shade B union A intersection, C complement, like that. Okay, so how are you going to shade this one? First and foremost, what do? We have to first distribute, or you have to simplify. So B union, distribute the complement. When you distribute the complement, it will be on A. The symbol changes to union. Then C, it has a complement plus that other complement. The complements, they cancel out each other. So this is the simplified form. Now, how are you now going to shade this one? Now we've got two sets. We've got B and A union C. Okay, so let's say this is our A and this is our C. This is A and this is C. Then there's also a B. Now where are we going to put our B? So you have to first find what A complement union C is, because you don't know where B is going to fall. So what would be our in layman's angle, let me say this is our Venn diagram. Okay, allow me to draw it big because I don't know where B is. So let's say this is a Venn diagram. Okay, so our A complement, it is what is not found in A. Okay, then you are uniting it with the C, and C, it is this part. Okay, now you are uniting this with the B. Okay, now you're uniting that with B. So now what do you now do? What you now do is whatever you have, you combine with B. Now where are you going to put your B? So you can put your B to be even here. Just make sure that you also shade this part, because you want to find what is both, everything that is in B and everything that is in like that. So this is how you're going to shade this other part. So thank you, see you in the next sessions.